The connection between physical reality and the mathematics used to describe it is a highly interesting concept to which a generous ratio of the population has thought to consider. A popular anecdote amongst the general public in this intellectual pursuit is that the golden ratio has an intrinsic, almost mystical connection to the universe and its existence. This is typically conveyed from a visual aspect using pictures with superimposed spirals like the ones you see here. This is a result of laymen misinterpreting the concept of logarithmic progression. The spirals found in nature, like the formation of galaxies, a nautilus shell, or the vortex formed by a fluid going down a drain, are not spirals that follow the golden ratio specifically. They are instead just a general form of logarithmic spiral. However, there is in fact a connection to nature that is specifically tied to the golden ratio. This is connected to the concept that the golden ratio in mathematics is considered to be the most irrational number. An irrational number is a number that cannot be represented by a ratio of two whole numbers. Therefore, it will have a decimal expansion which has infinitely many figures that never repeat, such as pi. You may wonder how something like the irrationality of a number could possibly be measured, but the concept is surprisingly intuitive to understand. To begin, consider that irrational numbers can be approximated using rational numbers, or ratios of whole numbers. Using this concept, we can construct something called a continued fraction. I will demonstrate this concept using pi. First, we note that pi is equal to 3 plus some fraction x less than 1. The goal is to find the whole number whose reciprocal most closely matches the quantity of the fractional part. Since every number is the equivalent of writing it as a fraction over 1, and a reciprocal is the equivalent of flipping the fraction over, we can subtract 3 from pi and then write its fractional part under 1 so that we have 1 over the fractional part of pi. This will give us a new number, which will be a whole number plus another decimal part. In this case, it's 7 plus its fractional part. So now, we're going to want to repeat those exact same steps for this new number. After repeating those steps, we find that the next number is 15. This will be followed by a 1 and a 292. What you'll want to notice is that 1 over 292 is a very small number, and is a measurement of how precise this continued fraction is at this point. Meaning, the larger the number, the more precise the continued fraction will be at this point. Using this concept, we can conclude that there must exist a continued fraction in which the entire series is composed of only ones. This means that the continued fraction is always as imprecise as it can possibly be at every given point. Calculating that continued fraction gives you the golden ratio. It is also important to note that as the Fibonacci sequence grows infinitely larger, the ratio between any two consecutive numbers within that sequence approaches an infinitely more precise representation of the golden ratio. The reason it is important to understand this concept of irrationality is because it is key to understanding how this number manifests itself within nature. That is because the golden ratio is encoded in some of the growth patterns of plants. Maximizing the efficiency of photosynthesis can be accomplished by maximizing the amount of surface area exposed to the sun. And when you have a plant in which the leaves all grow from a central structure, the best way to optimize the amount of surface area exposed to the sun is to minimize the amount of overlap that occurs between the leaves. Mathematically, the best way to do this is for the leaves to grow according to an angle of divergence equal to the golden ratio, measured in radians. The same process governs how seeds are distributed on the bulb of sunflowers. This is because, mathematically speaking, it maximizes the amount of seeds which can grow on a bulb of any given size. So, to answer the initial question about the unreasonable effectiveness of mathematics to describe the nature of reality, the answer, in my opinion, is no. Mathematics is not unreasonably effective. Its effectiveness is instead perfectly reasonable. In fact, I believe the connection between mathematics and the nature of reality to be so deeply rooted that new theories and new proofs in pure mathematics itself can actually help us discover new things about the nature of reality itself. But that is a video for another time.